let's get started. So first of all, just to introduce ourselves so you know who you're talking to today. First of all, hi, I'm Helen McKenzie. I am a geospatial advocate at CARTO. So that means my job is basically to get people as excited as possible about location data, which means I have the easiest job in the world because I think it's just the coolest thing ever. And also with me today is my amazing colleague, Ryan. Ryan, I'll hand over to you to introduce yourself.
Yeah, hi, Ryan Miller. I'm a solutions engineer with CARTO, which basically means I get to work with customers and help them identify how both geospatial data and CARTO specifically can help streamline their business needs and kind of extract value out of their location-based data. So super excited to be here today.
Great. Thanks so much, Ryan. So, enough about us. Here's what we have in store for you today. On the agenda, we first of all have the rise of real time. So, we're going to be talking a little bit about why real time data and analytics are really starting to take over the geospatial landscape. Then, we're going to talk about how you can build for success with real time. So, talk about some of the barriers and issues and blockers that some of you guys might have when working with real time data and how to remove those barriers so you can really start to build for success. And then we're going to put some of that into action and show you how you can actually start to do some of this really cool stuff. So without further ado, let's get into it. The rise of real time. So first of all, in case you're joining this call and you have no idea what I'm on about and you have no idea what real time is, let's start with a couple of quick definitions. So first of all, real time data. It's quite a self-explanatory name. It's data which is available as soon as it is generated. So there's absolutely no delay between the generation and creation of the data and when you, the user, can start to use it in your analysis. Near real-time data is kind of very similar, and to be honest with you, they're often used interchangeably in the data world. But with near real-time data, there's often a slight delay between when the data is generated and when you can start to use it. And generally, this is accounting for things like processing and validation. So often the delay we're talking about here might be a few hours or a few days, but it's basically the delay is very, very short. So that's real time and near real time. So to kick things off, very sorry to do this all to you, but I've built in some user participation into this call. So I'd love to hear from everyone on the call. We've got a Slido here that you can join by either scanning this QR code or by heading to slido.com and entering this code in 9562215. I'd just love to hear from all of you guys on the call. Are you using real-time data at the moment? Is it something you're using a lot? Is it core to your business? I'll just give you guys a couple of minutes to answer that question. For me personally, real-time data is something that historically I haven't used too much, and I'd say it's really only within the last few months that I've been using real-time data more and more, and that's part of the reason why we're doing this webinar, because I've been just really enjoying geeking out about it. So I've been loving adding it into my projects. So we've got quite a mixture in here, which is fantastic. So leading the way, we have about 40% of people. Oh, it's moving around. It's moving around. I can't I can't summarize this quickly enough. So it looks like the sort of two points here that are sort of leading the way are a mixture of people not using real-time data at all, and some people using it a bit, maybe for specific projects, but only about 25% of people here, 24%, oh, it's changing, are saying that real-time data is really core to their business. So hopefully there'll be something in this webinar for all of you to take away to work out how you can bring real-time more into the sort of core analytics of what you're doing. So just moving on from that, I think a good place to start here is to talk about how much data is actually real time. So at the moment, or actually not at the moment, in 2017, about 15% of all data in the world was estimated to be real time data, which isn't very much. But in 2025, we're now estimating that about 30% of all data on the planet is real time. So it's growing all the time and it's becoming far more common in the data sphere, which is a word I love, that real time data is becoming more and more common to organizations' practices. So what is real-time data? Where does it come from? Let's just kick this off with the basics. So real-time data comes from lots of different places. It can be satellite or weather data. We know that satellite data is kind of always on data. Satellites are constantly moving around the planet. It could be coming from transactions and point of sale data. So every time you go into a store and you buy something, or every time you buy something online, that is you generating some data, and it's data that's created straight away. Connected vehicles and routing is another really common one. So when you're sort of taking an Uber somewhere, when you're planning your route, when you're maybe hiring a dockless bike and traveling around the city, all of those things have telemetry data associated with them and are generating data all of the time. And lastly, and kind of probably the biggest umbrella of data, is mobile and internet data. So every time you're using your mobile phone, or every time you're using the internet, you're generating data. Often that data has a location attached to it, and that's generating a huge amount of data all of the time that is created straight away. So that's what real-time data is and where it comes from. Let's get into why it's becoming so important and why it's so valuable. For me, there's kind of three key things here that make real-time data so, so valuable. First of all, we have speed of analysis. So you're able to make much sort of faster, more agile, more on-demand decision making when you're working with data that is real-time or near real-time. And it's so much more relevant decisions as well if you're making decisions based on data that was generated today or yesterday compared to data that was generated months, years, even decades ago. So you're making not only decisions more quickly and on demand, more agilely, which isn't a word, but you're also making decisions that are much more relevant and accurate and precise to the now. Secondly, proactivity, I think, is a really big thing as well. So here I mean that you're much more able to mitigate and optimize your operations before issues arise, because you can start to see them coming. You can build much more accurate predictive models because you're getting the trends as they happen. That it sort of reduces the amount of surprises that you might see in your analysis because you're able to build on those trends all the time. And then finally, collaboration. So working with real-time data can really enhance teamwork, and really importantly, it can reduce versioning risks. So if everyone's working with real-time data, you don't get that terrifying question that comes up all the time, which is, what's the most up-to-date data here? Because you're all always working with the most up-to-date data. So you're really reducing that risk. So another fantastic statistic here, but we're really seeing a huge growth in not just the amount of real-time data that exists, but also the value that that data is generating. So it's predicted that in 2031, the value of real-time analytics will be 147.5 billion, which is absolutely massive. As of last year, 2024, that number was only 27.6 billion. So you can really see in the next 5 to 6 years how this market is set to really explode, and the value of this type of data and analytics is going to be really transformative. So where is that coming? Real-time data is kind of very cross-industry. There's loads of different verticals and use cases that can make use of it. I've just picked out a few here to discuss. So first of all, telecoms. I feel like this is quite an obvious one, particularly what I mentioned earlier about mobile and internet data generating a vast amount of real-time data. So there's lots of uses for real-time data in the telco world. An example might be real-time network optimization. So you can use that to adjust your resources based on demand patterns as they're happening. Maybe there's an event happening in a certain area. We've all been to like a massive concert where we can't get any mobile phone signal because everyone's on Instagram or everyone's trying to call a taxi. Being able to adjust your network and your resources in real time is really, really helpful to customer satisfaction there. And you can see in this brief little map what that can look like. So this is actually a visualization that came from one of our blogs recently that looked at footfall demand changes around the Paris Olympics and how you can see surges of demand and really pinpoint those to be able to inform your operations. So that's telcos. Another really key industry for real-time data is insurance. So the really key thing here is being able to predict claims instantly based on changing dynamic factors. That could be environmental changes, maybe extreme weather events or climate events, things like that. Or maybe it could be changes in customer behavior. And a really great use case here is being able to look at what's happening today and what's happening tomorrow and predict the value of claims that are likely to come into your organization. So there's no big surprises that tomorrow suddenly there's loads and loads of customers looking for compensation. And that's exactly what this demo is doing here. This is looking at real-time flooding in the UK and working out where there are likely to be claims based on real-time data. Next, transport and logistics. I don't think will be a shocker to anyone. Transport is a really, really dynamic world, and real-time data is absolutely crucial to making the best decisions in the transport world. So an example might be on dynamic fleet optimization. So where you have real-time transport conditions changing all the time, that might be traffic, that might be weather, that might be road closures, having access to that real-time, really precise data is absolutely crucial to making decisions. In this example map, we're looking at global shipping density, and that's sort of, if you think about transport, like traffic on your road when you're driving to work, global shipping density is that times 1,000. And then the final industry I just wanted to highlight where real-time data can bring value is marketing and advertising. Quite similar to telcos, one of the really key things here is around demand changes and human mobility changes. So if there's, again, I'll look at the example of events. If there's a massive event in a certain location, being able to target the customers and the huge surge of people that are spending time in that area is really, really crucial. And knowing when that's happening and being able to act on it straight away is so important rather than looking at that data maybe a year later. So that's a really quick overview on real time, what it is, and where it can really add value to organizations. Next, I'm going to talk a little bit about building for real-time geospatial success and how you can start to develop strategies to really take advantage of this data. So when I was putting this presentation together, I started thinking about what is it that that is a barrier for real time for organizations. Why are so many organizations not really taking advantage of it yet? And for me, there's kind of like three main categories for this. First of all, it's software and tools. So it's that maybe your tech stack isn't ready for real time. Maybe it's really hard to access real time data in your software and tools. Maybe it's about data and storage. So it's hard to find the real-time data that you're interested in. Maybe that data is absolutely massive and it's really hard to process that with your existing data storage stack. Maybe it's skills and knowledge. So maybe it's that yourself and your team don't have the skills that you need to be able to access that data, or maybe to find it and to process it. Those are sort of the three main categories that I see for barriers to real time. And over to you guys again. This is the last poll, I promise, but I would love to hear from the people on the call. What are your biggest barriers to going real time with your data analytics? Again, there's a QR code here, and I've got, you can head to slido.com to fill out this poll as well. I'd love to hear from you guys. While you're filling that in, I might talk a little bit about my perspective. So my background is, before I joined CARTO in another life, I was a GIS consultant for about 10 years. And I think I touched real-time data maybe once or twice. And the reason that I did that was very much my own skills and my own knowledge as a limitation. I, at the time, thought that you had to have very strong coding skills to be able to access real-time data, and particularly in JavaScript, and my JavaScript skills are absolutely rubbish. Anyone who works with me can absolutely attest to that. So I always sort of shied away from it and never really brought it into my analytics. And something that Ryan's going to be showing in a little bit is how actually just because you can't code doesn't mean you can't access real-time data anymore. So looking at these results, 59% of you are in the same sort of boat as me, I think, which is skills and knowledge, maybe not having the right skills, or maybe not being aware of how you can access real-time data and how you can process it. Then we're looking at software and tools as the next biggest category. So people not being able to, people's tech stacks not being very real-time ready and then data, and then something else. If you're one of the people who said something else, do feel free to drop in the chat what that something else might be, so we can all learn from each other. Thank you so much for filling in that poll. Promise that's the last one from me. Based on those categories, here are my sort of top tips for getting yourself real-time ready. We're going to start with software and tools, which I think was the number 2 in the poll that I just put together. So with software and tools, my biggest top tip is to simplify your data journey. I think this kind of goes for data analytics in general, that you will have a much easier time working with big data in general if your data has to go through fewer steps from where it was created to where you're using it to make a decision. So fewer migrations, fewer ETLs, export transport loads, transform loads, sorry. Just fewer different steps that it has to go through. That's kind of best practice when working with big data anyway. But with real-time data, because you have to work so much more quickly and because you have to maybe process a lot more data, that's so much more important. And you want your data to be moving quickly through stages because the data might be real time, but if your internal processes slow it down and it stops being real time, then you lose a lot of that value. So a simple data journey is absolutely key. And secondly, in relation to this is how important it is to be cloud native. So by reducing your heavy infrastructure management and having everything on the cloud, you can really simplify that journey in a massive way. And then finally, think big. So with real-time data, you're having to do an awful lot of data processing in comparison to if you're just using static data. There's no getting away from that. In particular, if you are wanting to not just look at the most up-to-date cut of real-time data, but look at real-time data sort of through time, then you really, really need to be scaling your infrastructure. So you should be choosing a scalable processing engine that can really handle those high velocity spatial data streams really, really efficiently. So that's software and tools. Next, I'm going to talk a bit about data, which I think was the sort of lowest category, but hopefully some useful stuff here anyway. So with data and any barriers you might have there, a really key thing is to be prioritizing automation. It's no fun if you work in data analysis and you're working with real-time data and you have to be sort of pushing the same buttons every single day. It's such a huge waste of your data team's time. So prioritizing automation and things and sort of setups that can streamline your ingestion, your transformation, and your analysis is going to save a huge amount of time and also just cut down on that data movement as well. Secondly, ensuring quality. So QAing data with real-time, QAing with real-time data is much more challenging because you're having to work so much more quickly. There's so much more data to QA or quality assure. So it's really important when you're building those automation pipelines that you build in validation checks, and maybe you're leveraging ML and AI to be able to do that, but taking all the sort of manual work out of that where possible is going to really help you. Then finally, we have handling data velocities. So it's really important, and I'm going to talk about this a bit more in a second, that you consider varying data velocities, so how often data is generated when you're building these pipelines. Some real-time data is generated literally every hour. Some data is generated every day or every month. And you're also probably still going to be using that real-time data in conjunction with data that is static or is not generated as frequently. So it's really important to build your pipelines in a way that accounts for both of those things. And just taking a brief sidebar to talk about those. So earlier I was talking about some of the data that very much is real time and where that comes from. But actually there's still a lot of data that isn't real time ready and that has a much slower velocity. So examples of that include demographic data, and I'm particularly thinking about census data here, so you might be able to tell from my accent, I'm based in the UK. Our census is updated every 10 years. And there are a lot of demographic data sets which are updated more frequently. But if you're looking for accurate real-time demographic data that is sort of saying today this many people live in this census block, that's going to be really hard to come by. Similarly, economy and industry data tends to have a bit more of a lag. So things like how many companies are based in this location, what is their industry, how many people work there, that sort of thing tends to have quite a lag to it as well. Thirdly, crowdsource data. So working with location data, crowdsource data, sources like OpenStreetMap are super, super important to a lot of us. But that's the kind of data that, because there's no one sort of managing an update schedule, there's always going to be a bit of a lag to it. And the data will actually have varying velocities within that data. And then finally, I just wanted to mention there will be a slight geographic bias in real-time data. So generally, urban areas will have a lot more real-time data available, mostly because of the proliferation of sources like these, like connected vehicles and transactional point of sale data. But also different countries will have different velocities of data available as well. So finally, I think before I hand over to Brian to show you some of the fun stuff, the final sort of area to talk about is skills and knowledge, which I think was number one on the poll we just did on the biggest barriers. So my top tips here, I mentioned this earlier, but leverage low code is so, so important. So historically in the geo world, a lot of teams struggle with a coding bottleneck anyway, where not everyone can code. People can code to different degrees and different languages. And historically, this has been a real blocker for real time in particular. So if you can leverage low code tools like CARTO workflows, which you're seeing here, Ryan's going to show you that in action in a second, then you're eliminating that bottleneck as you go, which is really important. And I think it also is really fantastic that you don't necessarily need to be a developer to access real-time data anymore. Second top tip is to prioritize pilots. So it's not crucial to go sort of real-time crazy straight away and start making all of your data and all of your pipelines real-time. So maybe just test your approach first on some smaller scale projects before you go for a full-scale rollout. So then you can really work out exactly what in your infrastructure and team and data needs sort of fine-tuning and what actually is real-time ready already. And then final top tip, and this kind of goes for everything, not just skills and knowledge, but don't forget decision makers. I think it's really easy with any sort of data developments and when you're changing up your pipelines to just focus on your technical team and the how. And I think it's really important to make sure you bring your decision makers on a journey with you as well, so they know the value that they're investing in, and likelihood is they'll be really excited by it. So that is actually everything from me. I'll stop talking now and hand over to Ryan so he can show you some of the really cool stuff of this in action.
Cool. Thank you, Helen. Yeah, so when you got the next slide. When we start talking about architectures, we kind of fall into this paradigm where our GIS databases are kind of silos. We have our business data that is kind of aggregated and consolidated, and then the GIS data has historically kind of been off on its own, which certainly has some implications from a real-time perspective, because a lot of the data could be coming in on either side of this barrier. And so trying to integrate those data for real-time analysis becomes a significant challenge. And so ultimately what we're trying to accomplish on the next slide is bring everything together. And this is kind of where CARTO fits in, where we bring all of our data into a single data warehouse, where our geospatial data sits right along with our data from our BI tools, our CRM system, our document data. And this allows an opportunity to integrate these data and extracts analyses and insights that are challenging if these data are segmented. All right, so next slide. And so what CARTO does is it really breaks down this data silo. And so what that allows you to do is, as I mentioned, kind of have a single point of data that allows you to integrate, visualize, extract insights, and ultimately achieve the greatest value by combining your geospatial data and your business data. So on the next slide here, this is kind of CARTO's value in that it provides a unifying platform. So it allows you to manage the data that are sitting in your underlying database or data warehouse, and that could be BigQuery, Snowflake, Databricks, or AWS Redshift. Allows you to analyze your process at scale. And so basically take those source data and execute a series of whether it's transformations, joining, combining different types of spatial statistics to extract the most value out of your data, and then take those outputs and or those source data and visualize them on a map. So it allows you to create maps and share those data. We have the ability to, with GenAI, and I'll show you in a second, to interact with those maps via a conversational style of interface. And then finally, to build out custom apps that leverage the CARTO and your warehouse functionality into a custom branded, custom feature, custom set of workflows and capabilities to really target your end users' use cases. All right. So with that, now we'll start the fun stuff. It's risky enough to do a live demo, but then a live demo of real-time analysis is probably even riskier. All
You've got
right.
this,
So,
Ryan.
all right. Here we go. So, like any journey, you're trying to figure out how to implement something. Where do we start? We typically go to our favorite LLM and ask a question. So basically, the use case here, I'm going to pull data down from the National Weather Service that has some notifications, and I'm an insurance company, but it could be any of your customers. I want to take those polygons, intersect them with my customer data, and kind of see what the implications are and create a map-based interface. So how does my favorite LLM is Gemini. So how does Gemini say I should accomplish this task? All right, so first of all, we need to get access to the data, an API. Great, that makes sense. Here's an endpoint that we'll be using here in a second. The data is going to come as a GeoJSON. So we're going to have some sort of scheduling process. So we've got to have this kind of occur at some common frequency. Python code, perfect. That's my language of choice. We're bringing data in. We've got a long series of steps and processes to implement this. And I think this goes back to the poll question about skills and knowledge. And it becomes fairly complicated to navigate these steps to implement a real-time analysis or bring real-time data into your workflows and processes. So what I'll show you is how we accomplish this in CARTO through our low-code, no-code environment, and then our builder map, which is the tool that we have out of the box that allows you to visualize data. So what you're looking at here is our workflow environment. So basically, this is the place where you build out workflows and processes and take your source data and run them through a series of steps to extract value. So the first step in this process, as we saw from Gemini, is we want to bring the data in. So we have a component called import from URL, which basically allows these are our components, and think of these as pieces of functionality that we're going to string together to extract the process that we want to implement. So I'm going to import from URL, so I drag that onto the screen. I click on that and it tells me the inputs that we need for this particular component. So I'm going to need a URL. All right, so we go to our National Weather Service. Here's their API. If you navigate here, there's some examples, and it shows you, here's the GeoJSON where that contains their real-time feed of weather notifications. So I will go ahead and copy this URL. I will paste that into the URL over here, and then I'll go ahead and run this. And so basically what's happening now is it's making a call to that web service that we just were looking at, bringing those data down. These data are in a JSON format, specifically GeoJSON, so the geometries are encoded, and it's building a table behind the scenes that we can then incorporate into our analysis. So while that's running, it takes just about 30 seconds here. I'll start bringing in our data set that we're going to combine it with. So what you're looking at here is our view that I'm using BigQuery here. So this is our database, data warehouse behind the scenes. I've got a policy data. So this is, again, an insurance use case, but this could be your logistics, your transportation facilities, your trucks, et cetera. We've got almost 8 million records in this table, and we're going to combine these. So if we look, going back, our import of our API data took about 28 seconds. We take a look at those data, and we got a URL to show the link to that particular event. We've got some other information regarding the data. In here, we should have the event type. We've got the status, the severity. Where's that field? And some other detailed notifications. But basically, it has properties such as whether it was a storm, thunderstorm warning, fire watch, etc. And those are the types of data we're going to be rendering on the map. We also have a map-based view, so basically these would be the polygons that are incorporated in the JSON feed. All right, so we've got our notifications from the National Weather Service. We have our business data, and now we're going to basically do a simple intersection. So we've got a tool set in here called intersect, ST intersection. And basically what we're going to do is we're going to say, okay, we want to take our business points or insurance points in this particular use case, and we want to find where those two geometries, where the points from our business data fall within one of the notifications that's coming from the National Weather Service. And so basically what this is doing is it'll get a result set that basically filters out the 7.6 million points that fall inside of these polygons. So I've implemented this about 2.5 weeks ago. And one of the things that you're going to need to do as far as any real-time analysis is have some sort of cadence where you are refreshing these data. And so within our workflows, I'll point out why this is running. We have the ability to schedule these workflows. So you can specify the repeat frequency. So if you want it to be an hour hourly refresh rate, days, weeks, etc., you have the flexibility to schedule these workflows on a dynamic schedule that allows you to ultimately achieve your business objectives. All right, so that ran. Took 42 seconds to form that intersection. And so basically now we're left with the 15,000 plus insurance policies in this use case that are intersect with our notification polygons. So as these processes are executed within a workflow, they're stored in temporary tables. But our business functionality, we want to visualize these data on a map. So we need to save these into a permanent table so that we can generate a map and extract insights from those data sets that we're creating. So we want to save this data as a table. So we've got this functionality here, or if you wanted to send this as an email, that's certainly something that would be available. We want to save our output from our impacted customers. And then we also want to save our notification polygons to a table as well. So with that, I'll go ahead and specify where we're going to save these. So this would be saving them back to our data warehouse. So I'll save that into our webinars folder. And then we'll call this impacted policies. I'll save that here. Oops, wrong place. It goes there. And then similarly, we're going to save our notifications. All right. So there we go. So now we run this, and this should take just a few minutes here. But basically what we're doing is we're completing this entire workflow that's taking the data, doing the intersection, and then saving those to a table back in, as I mentioned, in BigQuery in this case, where we can then visualize those data on a map. So this whole process, as I mentioned, can be scheduled. It can be published via an API, a lot of different ways that these workflows can be executed. The other point I should make here is that all of these processes are generating SQL that's ultimately running against your data warehouse, which really provides an efficient, scalable way to process data effectively. And so it basically allows you to scale out processes, whether it's million, tens of thousands, millions, or billions of points to run them through these type of analyses. All right, so we've got our data saved to a table, and that's pretty much what we've got to show on our workflow side. So let me switch this over. And as I mentioned, I started this workflow here about 2 weeks ago, running it on a cadence of about every 6 hours. And so what we're looking at here is basically a map of the last 24 hours. Weather patterns aren't very exciting in the morning and tend to get more exciting over the day. And so a lot of these, this is looking at a time period from the last 24 hours to just now. And so what goes on, so let me just, so you can kind of get a visual of where your customers are impacted spatially. And so if these are visualized using our H3 index. So when we visualize data at scale, one of the tools that we like to use are these hexagons where we're aggregating data up to the standard mapping unit, which allows you to easily visualize trends over space. Um, and so if I turn these off, I should point out, this is our builder, which is our map interface. So here are our notifications that have occurred. I've styled these to show the headline, the description from the National Weather Service data. Um, and then you can kind of visualize the different types of information that are coming from the Weather Service, and then combined with your particular business data, or in this case, the insurance policies data. So on the right-hand side, we have a whole series of widgets, which can be customized so that you can, filter if you're in particular focused around a particular event. If you're a transportation company, you may be interested in dense fog events. If you're a insurance company, fire risk, flooding, etc., you can interact with these. You can filter um, these widgets, which update the data on the map. So you'll basically get the residual data that will be shown on the map will be the resulting results from the query that just was executed. And one of the newer pieces of functionality that we've brought to CARTO Builder is this concept of an AI agent. And so basically an AI agent takes the information, both the data and the widgets that you have on the map, and embeds an LLM. So it allows you to have a conversational interaction with your map. And so using CARTO AI agent, you can ask it questions such as, what type of information does this map provide? And so basically what this does is it analyzes all the data that it has available to it, and then will give you a feedback on basically what type of results it knows based on the information it has available to it. So it tells us what this map does. It tells us the number of policyholders impacted by weather notifications in the past 24 hours, property types, etc. And then you can ask it questions about the data sets. So for example, what property types are impacted? And if all goes well, it should give me a summary of the data that it found based on the information on the map. So basically gives you a summary of, here are the property types that have been impacted by a particular weather event. The other interesting thing that we've got in builder maps are kind of SQL queries, which allow you to say, okay, well, I may not be interested in all these different types of weather events. I may only be interested in certain types of events, such as what do we have recently? I guess a flood warning would be relevant for this insurance use case, and that's the only one within the last 24 hours, which obviously is a good scenario. And so that when you filter those out, basically it filters all of the data to only a particular attribute from your different input data sets. So it filters the map based on, in this case, just the flood warnings. So one of the values of performing a data capture, data workflow on a real-time basis at a cadence of every 6 hours in this case, is the ability to take those data and look at that through time. And so then this allows you to kind of see, okay, well, what type of events or how are my properties impacted in this use case by time. And so this is basically taking data from the past 2 weeks and visualizing those data both on a map and then also a time series graph. So it allows you to kind of combine the spatial and the temporal component to look at specific trends. And this is particularly important when you start incorporating things like machine learning processes that can be trained on your data to make and extract insights from your data to start making predictions and just extract additional value from this real-time data that ultimately develops into a data set that you have for training models and things like that. Helen, I think that is kind of summarizes or concludes what I have from the demo portion of the presentation.
That's fantastic. Thank you so much. I really enjoyed watching that. You make it look so easy. So I think that's everything from us, but I see we have a few questions in the Q&A. So let's go through a few of them. In fact, we have a few questions which are quite similar, which are all about how can we integrate ML and AI into these processes, which Ryan, you mentioned a little bit, I think, after those questions came up. But something else to mention on that is CARTO basically inherits the state of your cloud data warehouse. So whatever ML functions you're using in there, you can use in CARTO. We also have sort of ML specific components in CARTO workflows that you can use to bring ML into those. And we're also developing ML specific workflows extension packages to basically make that whole process even easier. So we have a blogger all about that on the CARTO blog. I'm sure we can send that out in the follow-up email. That's all about how you can leverage those packages to make doing things like integrating ML into your workflows even easier. Anything you'd add to that, Ryan?
No, I think what one of the values is you have your data science team that works on building these models, and these models would be encapsulated in one of those workflow components. And so basically, it allows you to take that complicated logic and apply it very easily across different teams within your enterprise.
Brilliant. Thank you. Okay, what else have we got? How can I find high quality real-time APIs to use? It kind of depends on your use case and the type of data that you're looking for. I'd say, and the country that you're looking in as well. I'll probably give quite a UK-centric answer to this. But I actually generally find that a lot of like local, like government bodies and authorities are really getting great at publishing real-time data. So for example, here in London, Transport for London publish amazing real-time data. A lot of weather services and environment agencies publish real-time data for exactly the reasons we're talking about. Like if you're working with weather risks, like flood risks or wildfire risks, you need to be working in real time. So it kind of varies depending on the use case, but governments and sort of public bodies are a really good place to start. Any top tips on that, Ryan?
No, I think you captured it. Same here in the US. A lot of government services, as well as certain companies also make their data available in real time as well. There's plenty of opportunities to find and incorporate real-time data into your workflows.
Great, fantastic. Thank you. We have a question asking if Ryan, you can share the workflow that you created so people can try and test it themselves. I'm sure that's something you'll be happy to share in the follow-up email.
Yep, absolutely.
Great.
Absolutely.
And we also have, now's probably a good time to plug the CARTO Academy, which is our online learning hub for resources like tutorials and videos to help you get started on your sort of location journey. And we have some great tutorials on there all about real-time data. Definitely go take a look there. And yes, someone just asked about the maps as well. I'm sure we're happy to share the maps too. Otherwise, I think that I'm afraid takes us to time. But if you had a question and we didn't get a chance to answer it, we'll be able to follow up with that separately. And otherwise, just one final thing from myself, which is, as I said at the start of the call, if you want to get in touch with either myself or Ryan directly, then you can find us on LinkedIn here. So if you have any questions and want to ask us directly, please do feel free to. Otherwise, thank you so much for coming, and I hope this has inspired you to start your real-time journey. Thanks, everyone. Bye.
Right. Thank you.